Hello chemistry fans, and welcome your faces back to Chemistry 1032 problem solving session here at the Academic Success Center. I am your host, Dr. Russell Betts, and I will be guiding you through this problem. Let's take a look. Chapter 6, problem 5. Complete the following table with the formula and name of the compound that forms between each pair of ions. Okay. It's our third video on naming compounds, so you might want to consider it to be pretty important. So here we have, again, across the top, a list of anions, and across the left-hand side, a list of cations. Let's take a very close look at our cations because we know these are ionic. We know that we have ionic molecules being formed here because we have cations and anions. And we also know that if we have a transition metal, such as nickel, we have to use Roman numerals. So we have to be sure, be mindful, when we do the nickel naming, we have to make sure there's a Roman numeral there. Calcium's in group 2. Group 2 metals do not need Roman numerals. Group 2 metals are either neutral, no charge, or positive 2. If a group 2 metal forms an ion, it will only be plus 2. It can't be anything else if it forms an ion. Lithium is group 1. Group 1 metals can only ever form cations. So they will not form anything else. So we don't need to put a Roman numeral. It'll only ever be plus 1. So nickel could be any number of different cations. So we have to give it a Roman numeral. It is a transition metal, so it has to have one. Calcium and lithium are not transition metals, nor are they tin or lead. So we don't have to, or we will not actually use Roman numerals for these two. It's actually not proper to use them, so we'll leave them out. All right, in 2 subsequent videos, I have addressed how to write ionic formulas. I hope that you understand how to do that. If not, please pause this video, go get a tutor, and say, I don't know how to write ionic formulas. And they will get you where you need to be. There's lots of problems they can help you with. If you do understand it, and you're comfortable with doing it, please continue following along in this video with me. Okay, now across the top here we have a bunch of ions, but now these are not simple monoelemental ions or ions from the periodic table. These are polyatomic ions. Many atoms make a charge. So here we have OH minus 1. 2 atoms are making a charge of minus 1. SO4 minus 2. 5 atoms are making a charge of minus 2. Here we have 5 atoms again making a charge of minus 3. So these are polyatomics. Now, there is a list, a table in your textbook that has all the names and charges of all the polyatomic ions you're going to have to worry about. And if you're one of my students on the exam, I will provide that table for you. You don't have to worry about memorizing all the names. However, these 3 that I have written here are extremely common. You'll probably just remember them from using them so much. So don't actively try to memorize them, but don't be surprised when you do. You'll just be seeing them so often. All right, so here we have nickel, and here we have OH minus 1. OH is called hydroxide. So the formula here is NiBOH2. Now notice around the OH I put parentheses. These parentheses are very important. They're telling me that in this formula I have 1 nickel cation and 2 OH anions. So you have to put parentheses around the polyatomic when you have more than 1, okay, to indicate to the reader how many you have. So this will be called nickel, open parentheses, 2, close parentheses, hydroxide. And got a little cramp there, I'm sorry. So that's nickel 2 hydroxide. All right, next, nickel plus 2, SO4 minus 2. The formula here will be NiSO4. Or, let me get a different color pen, maybe that'll help it stand out a little more. The naming will be nickel 2, because the cation is plus 2. Sulfate, SO4 minus 2 is sulfate. There we go. That looks a little better. Nickel 2 sulfate. All right, next. Ni plus 2 PO4 minus 3. The formula here will be Ni 3 PO4 parentheses 2. All right. If you do not understand where that formula came from, you should pause the video right now and go get a tutor and say, hey, I don't get this. Please show me how to do that. I've shown you in subsequent videos how to make polyatomic formulas. If it's still not quite clear, grab a tutor, make it clear right now. Don't wait, okay? If you're good, follow along. So this will be nickel parentheses 2, close parentheses, phosphate. Nickel 2 phosphate. Again, if that formula threw you for a loop, go get help. Don't wait for spring, because spring might come too soon. Get it straight, get it right, okay? All right, Ca plus 2 OH minus 1. This will be CaOH2. Again, the polyatomic must go in parentheses if you have more than one of them. Okay, the naming for that will be calcium. I know, because we've been doing transition metal naming, I know that a lot of you want to say calcium 2. That would be incorrect. Calcium is a group 2 metal. You do not use Roman numerals for group 2 metals because they can only ever be plus 2 if they're a cation. So it'll be calcium hydroxide. Calcium hydroxide. No Roman numeral. Group 2 metal. No Roman numeral. Roman numerals are only for transition metals, and in this class you use them also for tin and for lead. All right, next. Ca plus 2, SO4 minus 2, that will be CaSO4, because the charges line up. If this formula or any formula throws you for a loop, pause the video, call for a tutor. That's the advantage of doing your problems here at the Academic Success Center, where tutors are readily available. Calcium sulfate. Calcium sulfate. All right, moving right along. So we have calcium plus 2 and PO4 negative 3. So that formula will be Ca3 PO4 2. Again, any formula that gives you trepidation or makes you feel sick or whatever, you can't figure out how the heck did I get that, pause the video, run to the tutor, call a tutor, somehow get help. Don't let it slide by. It's very easy points on exams. This is calcium phosphate. Calcium phosphate. All right, next. Lithium plus 1. OH minus 1. So the formula here is LiOH. Naming would be lithium hydroxide. Notice, we did not use a Roman numeral here. That's because lithium is a group 1 metal. Group 1 metals do not require Roman numerals. See, I'm harping on this because I've seen that mistake numerous times. I've seen it take people from getting a solid B to getting a solid C because they forgot that kind of stuff, that group 1 and group 2 don't need Roman numerals. Please do not fall into that mistake. I don't want to see you fall below an A if possible. Lithium plus 1, sulfate minus 2. The formula would be Li2SO4. And the name of that, let me go back to using the black marker, it seems to work better. The name of that would be lithium sulfate. Again, no Roman numeral. Lithium is a group 1 metal. So any group 1 metal, when naming in an ionic compound, does not require a Roman numeral. Don't use one. Only transition metals, tin, and lead. All right. Lithium and phosphate. The formula will be Li3PO4. Pause the video. If that gives you trepidation, call a tutor. Get a tutor to help you with that. It's very simple. Don't let it slide by. So this will be lithium phosphate. No Roman numeral. Just the names of the element of the metal cation and the polyatomic. All right. Now, if anything in this problem set gave you problems or gave you trepidation or you can't do it, call a tutor. Get help from a tutor or go to your professor's office hours. Please do not let this stuff slide. They're very easy problems if you work them. So please call a tutor here at the Academic Success Center or go ahead and go to your professor's office hours. Don't let this sit back. You can do it. All right? Now with that, I want to wish you good luck and good chemistry.